Hi everyone, in this video I'd like to talk about a modular arithmetic for n equals 2. And to motivate this, I would like to make two connections. The first thing I'm going to talk about is our standard clock with 12 numbers on it. And then I'm going to transition over to a clock over here, which I will, in a moment, label with two numbers. And for those of you in a real analysis course, I will note that a group, meaning an algebraic group, with two elements is actually a field with two elements. And this holds more generally for any prime number. So if you're working with n equals a prime number. I won't go into that theory too much here, but if you are reading a real analysis book and it talks about fields with two elements, it's exactly what we're talking about with a clock with two items. Okay, so that's to give you a little bit of context. But let's work through our familiar example. Let's start there from something we know and love, which is our clock with 12 numbers on it. And if someone were to come up to you, let's meet 2 hours after 12 noon, one thing you could do is you could say, okay, 12 noon plus 2 hours, that equals 14. And sometimes people in the military will go around and say, let's meet at 1400 hours at the dock. But, you know, when we are working with these clocks, if we were to count 2 hours past 12, that brings us to 2 p.m. So we kind of know and love this idea of reducing mod 12. So you can count around this clock. There is this idea that after 12 is 13. In other words, 1300 hours and 1 o'clock are somehow the same. Or if you're thinking about modular arithmetic, 1 is congruent to 13. And you could keep going around this clock and counting 14 is equivalent to 2. You could say 15 is equivalent to 3. Okay, so now let's talk about a field with two elements in it, or a clock with two numbers on it. And I'm going to label my clock over here with just the two numbers, 1 and 2. And so if I were to start counting around this circle, I have 1 o'clock, 2 o'clock, and then 3 o'clock would sit here up at the top of my picture. And then 4 o'clock would somehow be down here, and 5 o'clock, and so forth. And 6 o'clock is also down here. So there is this idea that somehow 1 is congruent to 3 and to 5 and so forth. So when we look at modular arithmetic, I could ask you, what is 1 plus 1? And you would tell me, well, that's equal to 2. And that's true, and that's certainly true in the integers, but sometimes you will see that 1 plus 1 equals 0, and again, we're working in mod 2 or a group with two elements or field with two elements, and the reason that 1 plus 1 equals 0 is because that 0 also sits at this position on my clock. So I've started to make this analogy where all of my odd numbers are up on top and I count around. That pattern is true. If I count backwards, what comes before the 1? Well, that would be the element 0. And so that also lives down here. 0 is congruent to 2. And so you can actually make a table, an addition table. You can look at multiplication tables, modular, 12 or mod 2. And those are really fun to do.